Hi, Bharat, can you hear me or? Hi, guys. For today we have the training session scheduled, so I think we'll give it some time here, perhaps 2 minutes, a little bit more, just to see who's going to join. Hopefully we can record this as well.
Yeah, hi, Jonas. That was my question. We can record this, or?
Yeah, that's what they have done in the past. Having stated that, I mean, I see a record button. I can click here. I'll try that later, but I haven't done that in Zoom before. So let's see if
I mean, my Zoom. Okay, if I look at the top of the top left, it says already it's recording. I'm not sure if it's already recording. Could be.
Yeah, you're referring to the blinking red animation of a red LED here, right? Yeah.
Yeah, exactly.
I'm hovering and I don't see, but that could very well be the case. Let's see if we get some LF person showing up here. I'll fire up Slack as well, see if I can ping these guys. I wonder why I have an option to record as well if it's already recording. Oh, Alex, you are here. Good deal. Alex, do you know if this is being recorded? We can see this blinking LED thing up in the left, but there's still an option to push record, I guess. And if you're talking, you're on mute.
Hi, sorry, I was on mute. Apologize. If you could only see what's happening outside my windows.
What's going on? Fires, aliens.
Have you ever been to Beijing in the dead of winter, like around March, or I'm sorry, January or February, when you can't see two inches in front of you because the smog is so bad?
Nope.
Well, I've had the pleasure of experiencing that a number of times, and this outside my windows is a very, very, very close second. It's yellow and it's brown, and the air just doesn't look very good.
Yeah, it sucks. We had the same situation in Fort Collins because we have a fire very close in Colorado, but then we got a snowstorm in September. So now the air is very fresh. But yeah. Do we have anybody from the, Bob, do you know if this is being recorded?
Yes, it is recording.
Okay, perfect.
Oh, it is recording now.
Yeah, it's automatically recording, I think.
And we can get to that recording and publish it later. I put it on the wiki somewhere.
What I'm finding is that Lewis from Linux Foundation must be posting it, because every week it just gets put up there, and I'm not doing anything to achieve that. So
it's either that or it just happens, through.
Okay, that's very cool. As long as we can stick it there and refer to it as the training for new people coming into the project, I think we're in a good situation.
Yeah.
Bob, when you see that posting come up, we'll start another column on the front page that says getting started with ODIM, and then we'll put developer training under that. So
Okay.
everybody can find it right away, as opposed to, without having to look through a million different recordings. I just want to single that one out.
Yes.
Yeah. All right. So do we think we should get started here? And
Yeah.
I think, yeah, okay. So
is Raffle on? I don't know if other folks are.
Yep.
I see folks as well.
Yeah, we can see him. I just want to introduce Barath. He's been dialing in here before. So well, Barath, do you want to introduce yourself and Shiva perhaps?
Hi team. Can you hear me?
Yes, we can.
Yeah. Good morning, afternoon, and evening, wherever you are. I am with the Genesis team here in Bangalore. We work on the ODIM RA and the plugin softwares, and I'm the architect here. And along with me, we have the lead Shiva, who's going to be demoing the build process, and maybe if time permits, a small demo on how to add and remove systems from ODIM.
So, Barath, how do you want to run this? I guess we have plenty of time for discussions as well. Do you prefer if people are asking questions while you're presenting, or do you want to postpone that till after? I mean, it's up to you.
I'm okay with both, but I think for interest of time and progress, we can. What we actually planned was 40 minutes of this demo, and then 20 minutes of question. If we, yeah. All right. So I get started now.
Look how wonderful our logo looks there. Yeah, cool.
Yeah. Yeah, this was for people who weren't aware, this was the one that was selected as a logo for the ODIM project, open source. And today I'll be talking on the software architecture and also running you through the repository structure and how things are structured there. And after that, Shiva, my colleague, would give a brief intro on the dependencies and the tools needed to have set up. And currently we are using setup using a Docker image, which is find, and the team finds it's easier to work with the bare VM or host. But if anyone is interested in this, we can cover it later and get back to them on that. We were doing this earlier, but we have moved it to Docker, which is much simpler. All right, so I'll start off. So this is like a rough architecture diagram. We have the API service in between. Not to be confused with the Docker or anything. This is just the ODIM API service, which basically is the endpoint for communicating from a northbound interface. And this is actually the only interface given to the external world. And it uses HTTPS. The details of that I will speak in the next slide. Right, and we have aggregation service for the new aggregation services that was introduced to Redfish system. This US here is for microservice. Maybe
possible to, when we publish these slides, is it possible to create legends for abbreviations so that we know?
Yeah,
what
we'll do that. Yeah, sure.
Cool.
Then we have the system microservice. All these components are, Redfish schemas are implemented as microservice. We use this thing Go Micro as the platform for communication between the various modules here. And Fabric collection is obvious. Manager for the manager schema collections. And then account and session services are clubbed as one microservice, and the event service for publishing the events. If you see,
can I ask a question? Sorry.
Wow, that came across a little garbled.
Somebody from the witness protection program, or? Can you
Maybe
guys
you can.
can you repeat the question? You came across very garbled. It was
So I just asked, can I ask a question? Is it right that communication is based on RPC?
Sorry, we can't hear you. Could you type in if you're it's
Yeah,
possible?
type in the question perhaps in the chat and we can get to it.
Yeah. Okay, so till we get that question anyway, I'll continue. So the event service is one of the top services. I think it's going to be the busiest in ODIM. And there's some other open source components like console, etcd, which have not been directly represented here. If you wanted to keep it simple. So if you see this below, we use Redis as the database, and we don't use any schemas, or we don't try to create any hash map or anything like that. Things will become apparent as we go. Then we have the task service, right? And then if you see here, the dark blue elements, they represent the HTTPS interface between ODIM RA, which is just about above the Kafka, and it connects the plugins. Now, currently we have the compute plugin and fabric plugin. Storage is not yet there. We'll have to see the swordfish rectification and then proceed with that. So this is a basic architecture.
Can I ask
And
a couple of questions?
yes.
These services, they are, so in terms of communication between the microservices that you have on top, it's a service mesh type architecture? Do you have sidecars? Do you have, independent scale out? How do you manage that?
Yeah, so good question. We use Go Micro as the communication thing. So this almost a full mesh architecture, I would say. And especially if you see task service, and API internally forwards it using Go Micro itself. And in terms of scale out, yes, we do think that someone like some service like event service will have to be scaled much more than others. But then even aggregation service we can scale up. The design is like such that we can scale them up, and that's the reason we had this Docker and
But I
currently
guess,
have.
yeah, Docker is a deployment,
Yeah, yeah.
right? But I'm just sort of trying to understand. So each one of these services will scale independently, and
Yes.
there is a single point of entry, just like ingress and egress, just like in the service mesh architecture, right? That's what I'm getting out of it.
Yes, yes.
And
API service is the only ingress point. Currently, there is no egress we have configured, but API service is the only one.
well, but
And
API service returns values, right? So
I didn't get that question. API
So
service?
when you say ingress, there's a northbound interface that exposed by the API service, right? And
Yes.
it's a two-way interface.
Yes, yes.
Okay. And then, so all of these are loosely coupled. They're not tightly coupled. It's not that these microservices are somehow plugged into the API service. It's just that this is how they're logically arranged, right?
Yes, yes.
Okay. So second question, task service, is that a microservice as well?
Yes.
Okay. And Redis obviously isn't, or is it?
No, Redis is just Redis in
Standard.
database, right? Yeah.
Okay. All right.
Yeah. There is no only open source allowed thing modules are there in Redis.
Mhm.
We don't have anything that needs license. All of them are covered. And by the way, everything in this, including whatever components, we have ensured that it's all open source and usable. Like most of them are Apache or BSD.
Is the and the third question is compute plugins, all these different kinds of plugins, right? Which may in the future be more than just these three, let's say. Is there like a plugin manager? Is there something that keeps track of all these plugins and knows that they've been registered and knows what to hand off to whom?
Yes. All the plugins register themselves within the manager collection, So when we add a manager plugin, that would be added to the manager collection. That is
Manager.
actually, yeah.
Okay, eventually. So, but today, how does it work? then
Not eventually, sorry. That's why I said it is even now, whatever plugins we have, they are, when we add those plugins, they're added to the manager collection.
okay. And okay, I see. And so the routing between the northbound API service invocations and the plugins, that happens how?
That is through the HTTPS connection. We wanted that to be generic so that, this, whatever development our team has done is on Golang, but we didn't want everyone to be restricted that way. So any language has to be supported. That's one of the reasons HTTPS interface is used.
So is
There's
that
a standard.
is this RESTful API?
Yes, but
Okay.
not currently fully Redfish, I think.
Okay, but okay.
So, Alex, there is RESTful APIs. There is also kind of trying to figuring out which plugin to use for certain operations, right? So there is that.
That's what I was getting at.
Yeah.
So.
But I think, yeah, if we save the question till afterwards and we try to run through this, I just don't want to have a situation where we run out of time and we don't have time to show the demo. So we can type them in, perhaps, like Rafael typed it in here as well, just so we remember to get back to them.
Okay, fine.
Cool. Thanks.
Yeah. So the last bit is, I think what's left is the red arrows. They are actually the calls to the Kafka message bus. If you see carefully, Kafka is only meant primarily to collect events from the plugins and forward it to the event service, which will do a processing and then send it to the uh, people who have requested for those notifications. In addition to the plugin, what happens is the aggregation service also creates add, delete nodes, which are basically logical operations. So you don't actually get events from the PMCs. So we simulate that event and post it in Kafka. Similarly, if anyone's registered for task service notifications using the task collection, we also forward that, and the event service picks it up and forwards it to the end user. So this is about the overall architecture. Shifting to ODIM components. So here, this package here represents the ODIM RA instance, and as we said earlier, like this can be scaled, and even in fact the various services inside which are depicted, that can also be scaled independently. They're all pods actually currently. So the external interface given to is provided is the HTTPS, which all requests goes through the ODIM. And if you see all these red interfaces, they're all HTTPS. So that means that, and basically we use only server authentication and then credential based authentication. But within the service mesh, we use certificate based authentication so that the communications are reliable. And nobody can just come in and post events, so we made it secure like that. And if you see all of the services, which is the same as what was listed previously, use Redis DB, but there is a abstraction so that in future, if we want, we can replace it with other node document based databases. And the interfaces in blue, they are what we marked as HTTPS, standing for HTTPS internal. They are they allow these microservices to talk to the plugins currently, which are compute and fabric plugin. And the data model is such that we have made them generic and call them compute and fabric. So there's nothing vendor specific, including HP specific in this ODIM array code, right? And then the last interface here is the Kafka, which is, as I said earlier, only used for the messaging part, event forwarding from the plugins. And if you see, there are some task service and aggregation also. That is because, as I explained before, right, these are for synthetic events and at the ODIM level. which are not generated from the plugin. And event and aggregation service also internally talk to each other with this Kafka sometimes. That's about the interfaces. So I'll proceed with the next. Okay, I'll just briefly touch on the message queue because this question had specifically come up before, So currently the message bus is using an interface. Though we only have Kafka, we have this interface. This distribute, accept, and close are currently implemented and used. Distribute is for publishing. Accept is for getting the messages, and get is currently not implemented because Kafka doesn't provide the semantics well. And remove is for the removing the subscription. This is also not implemented. We only consume and we don't unsubscribe anytime. And close is for closing the connection with the message bus interface. As I show you in the demo, the walkthrough, the code layout, the only implementation currently is for Kafka. We did start off with a few more before, but then this was prioritized for the initial phase. But if we want to add new message buses, it's only we need to only work through with the interface. Of course, the provider will have to have some initialization code, but the rest of the code uses this interface, so we won't be having any issues if we use the other message buses. And one thing before I proceed, I'm sorry, is that these communications which are shown in red, they're using HTTPS, but that's the transport used. Transport is also HTTPS because Go Micro allows you to use other forms like I think at least NATS and Kafka it's supported. So there's no reason to not use them as a transport, but I think HTTPS is doing good enough, so we didn't actually. And if you need support for that, it's just the code is such that you put that in the command line, and that switches the transfer from HTTPS to the actual message bus. Now HTTPS is used as the application protocol for this thing. So only thing we need to do is change the transport, and we can use other message buses if you want. Okay. So with this, I will go to the website for the project. So this is the URI of the project, and the default branch is development. So only when we are ready with the making the first release, we'll put it in the master branch. Otherwise, all development happens from the development branch. Our team uses forked repositories and goes to the standard process of approval.
Hey Bharat, this is Muthu from AMI. We are seeing the message bus interface screen. We are not seeing the other screen. What explaining?
Oh, sorry. I forgot to. Okay, I didn't realize I need to separately share this. Just let me know when you can see this.
Yeah, we are seeing.
Oh,
Thanks.
Thanks a lot. Yeah. So as I was saying, development is the default branch. Only a release, we'll put that in master. Documents was from LF Foundation, I think, who put the documentation bits. I won't touch on
I just want to say, I don't know that we had that discussion in TSC yet about the branching model. So this, what we're presenting here is obviously the proposed one, right? So we have everything going into development, and then once we get the project is getting ready to release, I think we'll either create a release branch and keep doing bug corrections there, and then finally we pull it over to master. That's a common approach I've seen. I don't think we should have that discussion now. My point was that just because we're showing you how it is done right now, doesn't mean that you don't have any input to this, of course.
Yeah. Thanks, Jonas.
Just procedurally, so I understand, this was the entire architecture session. Now you're kind of getting into the builds.
Yeah.
Okay. All right.
So this is the software layout, and then Shiva will be talking about actually taking you through the build process. So the first folder you see here is the build, where we have the build scripts for mainly ODIM arrays, the ones, and RF plugin have build scripts, and cert generator is for generation of certificates and stuff. And console and Redis only have configuration. There is no build. We just grab the standard Docker images and use them, right? So if you look at the ODIM, we have the process the scripts for generating all the Docker images, and starting on the start the whatever these things will go into the deployment. So all these are there. And if you see, say, Redis, we have the configuration files. That's all mainly. No create schema is there, which is used at the installation time, but nothing to build. And in Redis, we have two instances. One for the on this database, which will persist the configuration information, and transitory things are in the memory database. And also we wanted to keep those things separate so that the configuration database having all those credentials and stuff, we didn't want to risk losing much if there is a crash, just architecturally speaking. So we kept that distinct. Then we have the various libraries. So libdmtf, when we initially started off, we had a few models, which say like computer system and stuff implemented, which models all the computer system schema. This we don't use it currently much, except for some task related and eventing stuff, I think. Then is the lib message bus, the one that I discussed before. So the data communicator is where the actual code is there for the configuration header and Kafka com. This is the implementation, and I think config.go is where this is where the Kafka structure and set configuration. I mean, it reads the configuration file for Kafka, which was in that build folder, and it gets deployed, and then uses that to initialize the Kafka and similar code. Hey, Jonas, you want to say something?
No, I was just thinking, so config.go, you keep all the Kafka stuff in, and so that means that the message bus is kind of married to Kafka for now. So if we wanted to move in another direction, we'll have a different config file?
No. We'll have the same config file, but you see this Kafka com, it'll have say nats com or whatever.
Yeah. Okay.
Header and config will be common for both. So what we're going to have is, in addition to say currently there's only the Kafka thing, which is there, configuration handling. We'll add some new type for handling nats or whatever. So that will be something specific to the message bus, but the actual communication, if you see here, see this is the interface. So the users, which is the rest of the ODIM, will only consume through this interface. So depending on what is implemented, the rest of the code is protected from message bus actually that is used. So yeah, so Kafka.com will have to have the actual connection logic for the specific message bus. So, and when we add say support for NATs, we'll have to replicate that. But since the user only goes through the header, the interface in the header.go, the rest of the ODIM is protected. That's why it's extensible.
Yeah, that makes sense.
Yep. So I'll just move to the next one. Message bus is done. Lib persistence manager again is a wrapper for currently we only have implementation for Redis. Redis configurations right here, and then the Redis main methods are there here. Like getting a connection and sending a create request for a particular table entry. As you know, database Redis is at its core is a key value pair database, but it does have other data structures implemented on top of that. So we have added support for that here in terms of table, which basically is the key name along with the schema type also. That's about Redis. In future, if you have any document database we want to support, we can just straight away plug that in and work on this lib persistent manager, and we shouldn't have much work to do. But yeah, supporting something like Postgres or something will be more involved because.
So what are we storing today? Do you want to just highlight that, and what is in memory?
Okay. Yeah, so on disk, I basically briefly touched upon that, the passwords, the credentials, the managers that are added, all the config information which ODIM needs to contact the plugins and get the data, and even things like event subscription, which need to be durable, we'll store in the on disk. Whereas in memory, we will have all the inventory information. As soon as we add a node, the credential and other stuff are stored in the on disk, but the actual inventory, like all of the schemas, like systems and managers, chassis, everything under that is stored in cached in the uh, database in memory database, and it's not causing so much of a load, so but we have the option of some of them we like where need be, we will directly fetch from the device. And those kind of things are also there. So I would say that most of the data, the inventory data, is stored in the in-memory database, and configuration and subscription informations, connection informations are stored in the on disk. Does that answer?
Yep.
Yeah, thanks. The next one is the lib utilities. Lib utilities, the basic utility methods, whether it is service related, which is giving response to the user back, and this proto files, which is the Go micro proto files. We write this, and then the micro and proto buffer files are generated automatically. All this is stored, and then this is still proto. And then we have other thing like services, say this one is auth. So there are when the communication happens between different microservices, the request is again authorized to see if it's a valid thing, and so that nobody comes in and sends some malicious request or whatever. And session username is also used for some services. Like if you have some account related thing, the user wants to delete some session, we need to find out who the user is. Those kind of things are there here. Quicken the pace a little bit. I think we may run short of time. Then we have the first service, which is account session service. As you see, there is a AMD file. So whichever sorry about this. So library code are all in the lib folders, and then we have service, which is for the individual service. Here, account and session are club, but otherwise we have aggregation API and all those in separate things. The update is for the update service. We are still in the process of adding that. And even at the top level, we do have a a README file which tells you how to deploy ODIM array, build, and take care of all the prerequisites, including. And account session is, as I said, for the accounting. And most of the things, if you see, we have this various directories where the model, the response, and all those are separated out. There's folder specifically for authorization and role related stuff. And RPC is where the Go micro stubs will be, we'll inject the actual code for sending out the requests, So I just briefly try to touch on this. So this is create logic for a session. So creating a new session, we get the request from the HTTP. We use Iris for the router, which is open source thing. And so this is only for creating sessions. So we have other operations in the other files. We'll talk about it in detail when we go through the code flow, code walkthroughs. Similarly, like that, whatever, all of these are similar. You say if I randomly pick fabrics, we have the model response and RPC and fabrics, the core logic will be here. Main.go is for every module, it has the microservices initialization code. So things like, reading the, we prevent the users from being root. So only a normal user can run that for security reasons. And then checking the, setting the configuration, initializing the DB connection, and initializing the service as such, all that we do. And also register the handlers for the various methods, which are called from the service API. So if you see the service API, it's a little bit thicker because that does a lot more initialization, like setting up the router, because this is only microservice that sets up the router. The rest are consuming it, right? So, and the same configuration which we spoke about earlier, initialization service, and this is where we configure the HTTPS and kick off the Iris to run API server as HTTP server. That's about it. I mean, I can't cover all of them already. I think we're 35 minutes into the call. Yeah, any questions right now? We can.
There have been a few questions in the chat window. I've been trying to answer some of them. There was one from Rafael asking if the communication between the services are based on RPC. You were saying they're, yep.
Yeah, so all the microservices that the actual services that are hosted in ODIM, they communicate using the Go Micro RPC, and which in turn is using Go RPC itself.
Yeah, and then there
sorry,
was
Google RPC. Sorry, yeah.
So why not an event-driven? I guess is there a reason for this? Can we go to more of an event-driven model?
These communications are all synchronous, right? So we can event would mean that there will be other, like handling transaction and other stuff will be there. So we just took this because this reliable uses gRPC, and it was good. But
I think we can obviously come up with better ways of doing things, and we can propose them and we can discuss them. But this is more of how it works right now, yeah.
Yes, yeah.
So maybe the question should be asked differently, and this is why my last question on the chat. What is Kafka used for? I mean, do we have any sort of the synchronization between services via Kafka, Bas?
No. Kafka is only, as maybe it was not very clear in the slide. It's only for event forwarding from the plugins to the subscribers. So internal microservices, we don't have that event-based model. And as Jonas said, we're not close to that, but we just implemented it that way. And because most of our calls are all synchronous calls, right? I mean, that's a.
But how do you scale? I guess maybe I'm not sure if now is the right time to talk about this, or if we need a little follow-up Q&A. Maybe we should.
Yeah.
Jonas, I'm not sure. I mean, just a lot of questions about how these things interact, right?
Yeah, and I think the problem we're facing right now is that we're not going to be able to cover all the questions. So there are a couple of approaches we can take here. Well, one is that we will try to just answer everything we can in the chat. And if there's anything not answered, we get to that. And then we schedule the second session and potentially a third. If we keep using up the TSC slots, though, we're never going to get any TSC work done. So we need to make a decision on that, right? Right now, we have a pending demo that we want to show as well. So
yeah, let's maybe what we need to do is have a discussion as a separate meeting, maybe on a different day, but same time. And I'm still kind of hazy about sort of how things connect up, right?
Because, yeah, no, I get it. A lot of people are going to have a lot of questions after this.
I mean,
so we need to. So can we have a separate session? Should we try to find something around the same time but a different day?
We can. We would need to record it as well, because I can imagine somebody new coming in and saying, "Well, this is not quite enough, probably."
Exactly. So let's schedule that, and in the interest of time today, try to get the demo in as well, if possible. All right.
Shiva, you ready?
Yeah. Can you guys hear me?
Yeah.
So part of my demo, I'll be talking about the tools and prerequisites required for deploying ODIM, and also the second part of the demo, if time permits, will be adding and deleting a particular node. So for the first part of the demo, as you can see from the slide here, the tools that we use and prerequisites. So we have chosen Ubuntu 18.04 as the operating system for the deployment process. And part of the programming language compiler, we have used Go 1.13.7 version and bash scripts for Docker image build process. And part of tools which is used for deployment, we use Make and OpenJDK, Docker and Docker Compose. And as part of third-party requirements, we'll be using Kafka message bus of version 2.51 and Consul Go Micro for service discovery, registry, and inter-service communication. And we use etcd for config store, and going forward, we plan to use etcd also part of Go Micro. And the next part, as we saw in the architecture diagram, we use Redis with version 5.4.8. So Bharat, I'll start sharing my screen and I'll just show the deployment process.
Yeah, sure.
Thank you. Let me know once you guys can see the screen.
Yeah, we can see.
Yeah, for the deployment process also, we go back to the same GitHub link when we enter the project itself, the same README file defined under the project will explain the process of deployment. As part of prerequisites, as we saw, we'll need Ubuntu 18.04 and other prerequisites installed into it. The steps for those will be under the same README file. And also we'll have to set up a Docker environment, which is basically installing the prerequisite for Docker and setting up the Docker service, and also Docker Compose for managing the Docker deployment. And these steps just point towards what needs to be done for Docker service to come up and running. The next step is where we install the resource aggregator itself along with the generic request plugin. It also makes note about what ports are needed for all the services to run and for the plugin to run as well. Part of this, the user should first load the repo into their deployment VM and set the FQDN and the host IP. FQDN would be preferably in their format, and make sure that it's exported so that it can be used for the deployment process. And even in the FQDN, whatever is set along with the IP has to be mentioned in the etc host file. And the next step would include the certificate generation part. Basically here we have self-signed root CA and the other certificate keys with 4096 key length and SHA-512 algorithm. We use these certificates generated during this process to be pushed to be used by the resource aggregator while communicating to the plugin. And also the next step would be to make sure that if there's any intermediate certificate authority that has to be appended to the generated ODIM certificates. So part of this step, we make sure that we go into the certificate generator folder and run the certificate generation script with the input of the JFK that we set, and also certificate generation for Kafka. The next script is to copy these certificates into a specific etc folder to make sure these can be used by the Docker environment. Basically, we expose a shared volume for the containers to access all the certificates and make use of it for the communication end. At the end, we use make all command to build all the Docker images and deploy them using Docker Compose. And the next step is to verify if all the services are running. As we saw in the above section when we were going through all the folders, services were mainly defined with prefix SVC. So we can grep using that and make sure that all the services under ODIM are up and running. And the configurations files for ODIM part of the deployment will be placed under respective folders as mentioned in this README file. And even the logs will be under log. So whatever the ODIM containers are logging will be accessible on the host also, since we use shared volume part of the Docker Compose deployment. And for the next step, we have log rotation steps. If the user wants to continue with the log rotation and want to use it in a particular time interval, you can navigate to the cron jobs and make sure these particular log folders are in sync with that and monitor it. And finally, we have information about the default credentials, which is for ODIM array with basically when we deploy with make all, it will take about 10 minutes to bring ODIM up. Once it's up, we can use these particular credentials to access ODIM and the plugin via REST APIs. And finally, we have a link to aggregation service README file, which talks about how to add a particular node, delete node, and all the other operations that come under that particular aggregation service. All the supported endpoints are currently listed here. We can go through them, and the user can figure out easily how to add a particular node, delete, and all the operations that are listed here. And coming back, so as we saw, we didn't have to specifically configure anything in a specific config file as such. So all the deployment was done with default configurations. If the user wishes to change the configurations that is currently being set, he can follow the steps where he can get into the container, and there's a config file under a specific path. He can open it, go through all these options that he has. If he wishes to change any of these options, read through the description and change according to his environment and his wishes. And at the end, he can just restart the particular container, which is our ODIM container, and it will bring up all the services with this particular config that is set. So let me quickly switch to the demo environment. Okay. As we saw, we need all the certificate generation process and the prerequisites met. So we have the prerequisite Docker installed, and we didn't want to go through the installation process of prerequisites as it's apt install commands. For now, let me quickly run the make all command and explain the other processes by the time this completes. So currently we are in the ODIM project. We have done a git clone and we have the repo in place. Let me do make all quickly. This will take about 10 minutes to build all the services and then deploy them. So as we saw, there are a couple of third-party applications also, which is Kafka, etcd, Consul and Redis. Even those standard Docker images will be pulled from open source Docker Hub and will build and deploy the same here. So part of this make all process, we'll go into each and every repo folder of the service, which is say a concession service, aggregation service, and managers, systems, go through each of them, build, we run go build commands to create a binary out of it and push it into the ODIM container, create an image out of that and push it as a deployment process using Docker Compose. So I think this will take about 10 minutes. By then, do we continue with some questions, or can I switch to the second part of the demo? Anything is fine with me.
Yeah, you have 10 minutes, so why don't you switch to the second part? This is going to get built. We've seen it before. If something fails, then we have an issue.
Yeah. So the second part of the demo is where we add servers. So I have another VM where this build process is complete. So let me open up a REST API client where we have that current ODIM running, so that by the time that completes, we can see other operations, how we can perform them. So currently, systems URLs where we see the list of systems or VMCs or any nodes that are been added into the current ODIM environment. We can see that currently there are no members associated here. So part of this demo, I'll be showing add server, delete server. So also, since we were talking about how there are event notifications that ODIM handles, I am running a particular, just a simple client, which just takes in and displays the event notifications that is coming here. So part of this can act as a any user client that they have that wants to receive the event notification and make use of it. So first thing I'll do is create a subscription. So event subscription here I'll create for our systems collection and manager collection. Just to note that when a resource is added, the client which is defined here as the destination will receive a resource added and resource removed event notifications received there, and we can see how a client can make use of it. And we can define event types and make sure a particular alert types are also being captured there if needed for the user. So for this particular demo, I'll be showing just events for add and remove of particular node. So this is the same destination that I'm running as I showed in the CLI. Let me go ahead and create the subscription for any, since we are creating a subscription for multiple origin resources. We get a task service response where we monitor the task that is running in the background. We can see the status of it, the percentage complete, when it was completed, start time, end time, all the status of that particular task. And the task monitor itself, there's a particular URI which we can use to check the final status of the task itself. We can see that the resource created response was given by event subscription. We can also list the tasks and make sure that that task subscription is indeed present in our ODIM environment. Let me quickly switch to adding a plugin. So on default deployment, even though the plugin service is running, the user can choose to add the generated plugin that is already deployed as a container. So as we saw in the README file, the default configuration for Redfish plugin would be under this particular port, but the user can change it and deploy it with his configuration needs. So let me quickly add the generated Redfish plugin with a particular ID called GRF. Similarly, for any task, we can see the task status, if it's completed or not, and finally the response of the task itself.
I just quickly want to mention that the add action of the aggregation service does not exist in the Redfish release. By the time we were discussing this in the MTF, we were already developing. So there were some minor changes. You will see that instead of using an add action in the real released version of aggregation service, you will rather post to a collection of aggregation sources. So we get into that later. There will be a change made, and we already brought it up in TSC, so just so you know.
Thanks,
Shiva and Jonas, this is Rafa. I would like to learn how the plugins are, matched to the underlying BMCs, right?
Yep.
How the association is being done, and I'm intrigued by you have the dedicated as plugin, REST function, because my assumption was that all supported plugins would be part of the let's say deployment anyway, and you don't have to configure using the REST interface.
On the first part of that, absolutely, we will go through. There is a table in the database that is mapping to the right plugin. On the second part, I guess, Rafael, I'm not sure complete what you're asking. Perhaps I'll reach out to you one-on-one and try to understand your question there.
Okay.
Okay.
Yeah. So since the event subscription was done on managers also, since we added the plugin, the client will receive resource added event for the particular plugin manager that we are currently added into ODIM. Let's quickly move to adding a node. So currently we can mention which particular plugin ID to use for adding a node. The same URL will be used, but instead of a plugin, we'll be adding a server here. Same process, we return a task URL. When we do a get on it, we get the current status of the task that is still running. It will take about a minute to complete this. Currently it's at 3%, so it will just take a minute to completely get all the resources under the particular system, go to the number of CPUs, the NIC information, storage information, manage information, chassis information, get all of those and put it into ODIM for further retrieval. Just took about a minute. So you can just monitor this particular task URI to make sure the percentage, and once it's complete, we can see the status of the task, status of the response by clicking on the task monitor and retrieving that information. You can see that the request is completed. And if we look at the client, we'll see that there are 2 more events that came in, which is for systems of the node that we added, and the manager of the node that we added will be sent to the client as resource added events. So finally, we can also see that even the node added under systems that we have. And if we retrieve that particular system, we can get all the information under that system, all the resource information for that particular node. And let me just copy this ID for removal of node. For removal of node, we use aggregation remove action, and we present the ID of the node that you want to remove and send the request.
Again, will be updated to comply with the current spec
Yes.
on the aggregation service. Yeah.
And it's completely added. I'm sorry, removed. If we go back to the client, we also get the resource remove event from that is being triggered.
So Shiva, we're out of time. Did you almost reach the end of your demo?
That's the end of the demo actually.
So we have a couple of actions. We will try to schedule another call next week. That is not on top of TSC, but separate. We will upload the presentation, but Bharat mentioned that you also requested to add some legend and stuff. So we will do that before we upload it, and I will stick it under today's TSC minutes. And then for all the questions that are in this chat, we obviously will try to address the ones we didn't address. And feel free to also send out questions on the TSC mailing list, and we try to address them there as well. I know we ran out of time, and it's always a little frustrating, but we'll look for a new slot. Yep. If nothing else, I guess we end. Thank you very much.
Thank you. Bye, everybody.
Thanks, everyone.
Bye.
Thank you. Thank you all. Bye.
Bye.
Hi, Jonas. Yeah, I was clicking on the wrong window on the Zoom. So it's still unclear to me because I was distracted at the end of this demo. By the way, all the presentation and the demo went very well, I think. That that what puzzles me is this add plugin versus add BMC, and that what I was trying to tell is like you can add or you can use the explicit REST API to just provide the BMC or to be detected, but plugin stuff it should be compiled ready to be used. Yep. Yep. I know. Yeah, Alex, Bob. Yes. Especially that one of our engineers is ramping, the others also contribute on BMC stuff. So, and then Robert, the guy who showed up today, he had, lots of questions. Thank you, Jonas, for addressing them very quickly. I think and he's, asking me if he could have, the direct, connection to someone in HPE, right? Just to speed up the ramp up. For example, to have some chat with Bharat or whoever you see, the best to discuss on the development level would be probably very handy if doable. We can talk about this on Friday call. Yep. Yep. I think it makes sense. I think you set up the call for this, John, right, on Friday. Yeah, coordinate review and yeah. So Jonas, John, I'm puzzled because I was doing something in between. Is AMI not contributing Composer to ODIM? Yes. And behavior changes. And when you say user interface, you specifically mean the graphical user interface and not the let's say plumbing for the REST API from Composer being available at the Norbound server. Okay. Yep. Of course, ideal would be to use the same interface that is used in current resource aggregator, right, in Go. Yes. And by the way, I need to probably spend some more time to better understand your arguments with the, let's say, the resource aggregator and why do you organize the calls for plugin and the BMCs, and then we can discuss. Yes, absolutely. Thank you, guys. Znalazłeś buty, Marysi? Kurwa! Buty, Marysia, mam twoje, gdzie były? Nie zapinaj się, bo będzie gorąco. Otwieram wam garaż. Marysia? Marysia, masz moją komórkę?